This is the homework for 128, 129A and C, 130, and 132. For problem 128, you need to solve the equations. In A, we're going to solve this equation by cross-multiplying. So here, we're going to cross-multiply. Some people have called this the butterfly method. So m multiplied by 18 and 6 multiplied by 15. M multiplied by 18 is 18m. 6 multiplied by 15 is 90. Now we're going to simplify this equation. Inverse property of multiplication is division. And we're going to divide by 18 on both sides of the equations. This created the giant 1. 1 multiplied by m equals m. 90 divided by 18 is 5. And what I mean by giant 1, 18 divided by 18 equals 1. So it's a big 1 or a giant 1. For 28b, we're going to go ahead and solve it by cross-multiplying. And we get 7 multiplied by a is 7a. Pi multiplied by 4 is 4 pi. Now we're going to go ahead and simplify this equation. We want to isolate the variable. And we're going to do that by dividing this side by 7. The reason why we chose 7 is because it creates the giant 1. And identity property of multiplication, 1 multiplied by any value will be itself. So 1 multiplied by a is a. Here we have 4 pi divided by 7. So if we wanted the exact value, we would leave it in this term, 4/7 pi. The approximate value is 1 8/10. For problems 129, you need to evaluate absolute value expressions. So absolute value, these bars here, these vertical bars, show you that this is taking the absolute value of negative 100. Well, what does that mean? Well, absolute value is what's the distance from 0. So how many units would that be from 0? So negative 100 on a number line would be 100. If it was positive 100, the absolute value of positive 100 would also be 100. So when you have the absolute value, when you take the absolute value, it's going to make it positive. So now we have 100 minus 98 equals 2. 29b, we have the absolute values here, and treat these like grouping symbols, so GEMDAS. So we have to do the operation that's inside, so we have to simplify this first. 2 minus 8, well, we have more negatives than positives, so we know it's going to be a negative value. Signs are opposite, so we're going to subtract. 8 minus 2 is 6, so you're going to get negative 6. Well, now we take the absolute value of negative 6. What's the distance from 0 to negative 6? The absolute value of negative 6 is positive 6. Now we treat this just like any other grouping symbol. When you have a value right up against a grouping symbol, most of the time it means multiplication. So we have 5 multiplied by 6 equals 30. For D, I would like you to try to do this one on your own, and go ahead and pause the video now. So, order of operations requires us to do inside the absolute value symbols. So first we need to simplify negative 10 plus 3. We have more negative values than positives, so we know it's going to be a negative value. Signs are opposite, so we subtract. 10 minus 3 is 7, so it's negative 7. absolute value of -7. What's the distance from -7 to 0? That's 7 units. Now we apply this negative, and it's saying what is the opposite of what's inside that? So the opposite of +7 is -7. We have 14 minus 7 equals 7. Before we do problem 130, I want to do a little review. Here we have the square root of 16. Now, I put a 2 here, and that represents the square root, but you don't normally put a 2 there. You just know that this radical symbol is the square root of 16. But I wanted to put this 2 here, because here we have the cube root. Well, let's show what the square root is. The square root is what number multiplied by itself equals 16. So it's multiplied by itself 2 times. Well, when we factor this out, you get 4 times 4 would equal 16. So the square root of 16 is 4. Well, now we have the cube root. And so now you can distinguish between square root and cube root. There's a 3 here. And when you have the cube root, there will always be a 3 here. So what number, when you factor it out, multiplied by itself 3 times will equal 8? Well, 2 multiplied by 2 is 4, multiplied by 2 is 8. So the cube root of 8 is 2. Here's the cube root of 64. Well, when we factor it, we get 4 times 4, because 4 times 4 is 16. 16 multiplied by 4 is 64. So the cube root of 64 is 4. For problem B, what's the cube root of 125? Well, 5 multiplied by 5 is 25. Multiplied by 5 is 125. So the cube root of 125 is 5. Here we have the cube root of -8. Well, what number multiplied by itself 3 times would give us -8? Well, we factor this. -2 multiplied by 4 is -8. And then we factor 4. Well, -2 multiplied by -2 is a +4. And the reason why I didn't factor it as 2 times 2 is because, remember, for the cube root, it's the same number being multiplied by itself 3 times. So it's -2 multiplied by -2 is +4. Multiplied by -2 is -8. So the cube root of -8 is -2. For 132, we need to graph the data that was provided in the table. X represents the number of jumps, and the Y values is the height. The height is dependent on the independent number of jumps. So 1 jump, 5/10. 2 jumps is 9/10, almost 1, just below it, and so forth. And you just keep plotting the points. For 32b, we need to fully describe the graph. Well, you should have a couple of the things that I'm going to be mentioning. One, the graph is a curve that is going up. As the number of jumps increases, the x values, the height also increases. So you can see 1 jump, the height is only 5/10, but as the number of jumps increases, it ends up being 5 and 5/10. The points are not connected. So if I did not connect these points with a line, and that's on purpose, because this is not a continuous graph. What I mean by that is you can't have a half a jump. If I were to put a line here, that means that there are points in between these. And there's not. I couldn't do 2 1/7 of a jump. So you do not connect these points. This is called a discrete graph. The other thing is that we only used the first quadrant. We didn't do a full coordinate plane. There's no need for that because you can't have a negative jump. So if you don't need, if you can't do it, then you only create a one quadrant graph. For 132C, if you need a function to model this data, it would make sense to limit the maximum and minimum values for jump heights. Why would this be the case? So one reason you would have a minimum is she can't have a negative jump. So your minimum would most likely be 0 because that's where she's starting from on the trampoline. A maximum would be somewhere that would be what's a realistic height that she could jump on the trampoline. A realistic height maybe would be 10 feet. So our max would be 10 and our minimum would be 0.